Hello, welcome back to Cinderella Math. This is part 4 of a pre-calc slash trig midterm review. Yes, you heard that right, part 4. It is just very long, and also my pen dies after 30 minutes. I'm starting to think it's a Zoom issue. So anyway, sorry for all the parts on this. We're kind of on the trig part now, so go ahead, grab pencil, paper, calculator, and if you're allowed to use it, unit circle. All right, so the video 3 ended with some unit circle work. So if you need to see that, go back to the very end of video 3. Sorry for the really bad handwriting because my pen was dying at that point. So we're going to come here, triangle trigonometry. We will absolutely need a calculator for this part. Make sure you set your calculator to degrees. I'm going to come over to Desmos, to the little wrench in the corner, and set to degrees. Alrighty, hopefully the pen can make it through. Alrighty, starting, it's not numbered. So top left, it says find AC. So A to C would be right here. We're going to use law of sines. So here to here. So we'll say sine 28 over X equals, and then we're going to use this one with this one. Sine 92 over 15. Your fractions can be switched. Like it could be X over sine 28 equals 15 over sine 92. That is fine. It doesn't really matter. I just like the angles on top, but it doesn't matter. Crisscross multiply. So we're going to have X times sine 92 equals crisscross multiply 15 times sine 28. And then divide this off. And I like rounding to the 10th, but if your teacher wants it different, just do whatever your teacher wants. So we have 15 sine 28 all over sine 92. Make sure you're in degrees, 7.04. So I would just say 7 if I'm rounding to the 10th here. But again, we're round to whatever. So X or AC is approximately 7.04, and we are in yards. 7.0 if you want. Find AC. So right here, let's call that X. Okay, boop, boop. So I'm going to say sine 83 over X equals, and then we need this angle, and then over 25. So sine of whatever big C is. Remember from geometry that all triangles have to add up to 180. So I'm going to do 180 minus 83 minus 38. And that'll get us what, oops, I mistake there. That'll get us what AC is. So just in your calculator, 180 minus 83 minus 38 is 59. So angle C is 59. And now crisscross. So we have X times sine of 59, crisscross, 25 times sine 83, divide, and then again, round or to whatever your teacher wants, approximately. $25 sine 83 over sine 59. 28.9. And we're in meters. So those are both law of sines. Coming on down to the third one on this page. Find the length of little a. Probably going to have to go law of cosines here, because if you tried sines, you could set that one up. So you could do sine of 40 over little a, but we don't have a second one. We don't have big C to come with this, and we don't have big B to come with this. So we will go law of cosines. This is the one we want. So you do that one squared equals the two others squared and added together, minus 2 times those two others times cosine of the angle across from the one you want. Now this looks horrible, but this is all just numbers. So we're going to come to our calculator and very carefully type that in. Okay, so we have 32 squared plus, oops, plus 21 squared minus 2 times 32 times 21 times cos of 40. Make sure you're in degrees. So we have a squared equals 435.436, blah, blah, blah. Let's take the square root, take the square root. So square root, and then I'm just going to copy and paste that. And 20.86, I'm going to go 20.9. So little a is approximately 20.9, and they didn't give units, so that's the best we can do. Find angle A. Okay, again, we have to use cosines and come across. This is the one we care about, so that's going to be 14 squared, and then the other two squared and added together, minus 2 times the other two, times cosine of the angle A. Now this, we cannot just stick in the calculator because we don't know A. So we'll just do it baby steps. So go ahead, square out your numbers. You might know some of these in your head. Oops. 2 times 9 times 6. So just run that through the calculator. So 108. Okay. These two can go together, not the 108. That one's stuck to cosine A, but 81 plus 36 can indeed go together. That's 117. Solving for cosine A. So we can minus 117. Again, use your calculator whenever you need it. So this is 79 equals negative 108 cos A. And then divide that off finally. So we have cos of A is negative 79 over 108. I just like the negative on top. And then we're going to do inverse or arc cosine of that fraction. So arc cosine of negative 79 over 108. I can hit the right buttons. There we go. 137.0. So I'm just going to go 137. If you don't want to type arc cosine, if you hit the keyboard, hit the functions, inverse trig is right there. So that works too. Same thing. Okay, so angle A is approximately 137 degrees. Okay, so know your law of sines, know your law of cosines. And now it looks like we're coming to some trig identities here. If you're allowed a cheat sheet for this or like a formula sheet, feel free to grab that. You want to start with a more complicated side. So they've given us the answer. Prove that this equals this. Start with the more complicated side. So we're going to start with the left-hand side. Cosine's fine. And then you know cosecant is the reciprocal of sine. So that would be 1 over sine. And then we know tan is sine over cosine. And again, if you're allowed a cheat sheet for this, that would all be on your cheat sheet under the reciprocal section, and then the tan would be under the quotient section. Okay, let's get a common denominator. So I'm going to multiply this side by cos and this side by sine. So we'd have cos x plus sine square x all over sine x cos x, and then just drop this cosine. And then look, we can cross cancel. This cosine can cross cancel this one. Okay, so we're left with cos x over sine x plus sine square over sine. But then this sine can cancel one of these. So we're left with cos x sine x plus sine x. But cos over sine, this is another quotient that's cotan. And that has done it. We have proven it. Okay, yeah, I did not need to look at the formula sheet because I've been doing this for 20 years. You can look at the formula sheet as long as you're allowed to, and usually you are. Okay. Number 2. All right. All right, let's again, we're going to work with the left. So we have sine x, and then you could change this to 1 over cosecant plus cos 1 over secant. All right. But the flip of cosecant is sine. Like, again, this would be under your reciprocal identities. A cosecant on the bottom is a sine. So drop this one down. And then this is just sine. Plus, drop this one down. A secant on the bottom is just cosine. This is under reciprocal again. This is just cosine. So we have sine square plus cosine square, which is 1. That is the most famous trig identity. It's a Pythagorean identity. So if you have a cheat sheet, look under the Pythagorean section. And we've done it. Last page. Solve the following. Oof. Okay, so you're going to go on your cheat sheet and you're going to go to the double angle identities. See how this is sine of 2x? Go to double angle identities. And this is just a rule. And again, you usually don't have to memorize this. Usually you are given a formula sheet. Sine of 2x is 2 sine x cos x. So let's change that. So 2 sine x cos x plus cos x equals 0. Okay, see a cos, that's a GCF. Let's pull it out. So cos, that would still leave 2 sine plus 1, set to 0, set to 0, set to 0. So cos x set to 0, 2 sine x plus 1 set to 0. So we'd have sine x equals -1, divide 2. There we go. So we're looking on the unit circle for when cos is 0 and when sine is -1/2. Okay, so let's think about our unit circle. If you're allowed to look at it, feel free. So right here, this is over 1 up 0, CS. Okay, we want cos to be 0. So here, this is over 0 up 1, CS. So right here, that's an answer. Pi over 2. And then straight down, CS. That cosine is also 0. So 3 pi over 2. That's another answer. So this first one of cosine being 0 has resulted in 2 answers. Okay, so now where is sine -1/2? So all students, so not negative, not negative. So we'll have down here. Sine -1/2. So wouldn't it be this one right here, which is -√3/2 -1/2 CS, and that is 7/6 pi. So there's an answer. And then wouldn't it be right here? Like it should be a little higher actually, like here. Because wouldn't this one be right √3/2 down 1/2 CS? So we want the sine to be -1/2, and that is 11 pi over 6. Okay. So this question did not say, well, assuming that we are solving this from x is in between 0 to 2 pi, we have 4 answers. X is pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Okay. That's assuming that we were solving like on the unit circle. If it said give every solution ever, if it said solve from negative infinity to infinity, see how the pi over 2 and then the 3 pi over 2 are like half a circle away? And a whole circle is 2 pi, so half a circle is pi. We could say that our answer is pi over 2 plus a circle k times. So like, not a circle, excuse me, half a circle and then another half circle, half a circle, then another half circle. As long as k is an integer. Z stands for the set of all integers, by the way. Okay, and then the other two, the 7 pi over 6 and the 11 pi over 6, they're not like half a circle away. So we couldn't do that trick. I think you would just have to say 7 pi over 6, and then you could do a whole circle. That would also be an answer, and another one. So you would do 2 pi k, where k is an integer. And then you would do the same for the 11. So the two we were able to combine because they were a half circle away, but the other ones weren't. Okay. That's if it was for negative infinity to infinity. That's all the possible answers ever. The red answers are assuming that you're just solving on the unit circle. This did not say, so I showed both. Okay. Number 4. See, this one doesn't say either. That's annoying. Sorry. Number 4. This one, I'd like to factor it, but this says sine square and this says cosine. So using our Pythagorean identity, sine square plus cos square is 1. Let's solve for sine square. So let's move this over. Sine squared is 1 minus cos square. Let's make that adjustment. So 2, and then let's take out sine square and put in 1 minus cos square. And then the rest, let's just leave for a second. All right, let's distribute this 2. So that would be 2 minus 2 cos square plus 3 cos minus 3. Okay, 2 minus 3 we could put together to be negative 1. Okay. And now I'm going to just, can we just do this? Can we negate the whole thing? And then negate this? Because I would prefer a positive in the front. So 2 cos square minus 3 cos plus 1 equals 0. And now let's factor. 2 times 1 is 2. Middle number is negative 3. What if we did negative 2 and negative 1? So we'd have cos. So see how this is cos square? So each of your parentheses is going to get a cos. And then now your magic numbers was a minus 2 and a minus 1. But remember, when this is not a 1, he's a cheat. If you're not sure what I'm talking about, go back and watch part 1 and part 2. Divide 2, divide 2. So we get cos x minus 1 and cos x minus a half. Set both of those to 0. So you would get cos x equals 1 and cos x equals a half. All right. Think of unit circle. Where is cosine a 1? So wouldn't that be here? Because it's over 1, up nothing, CS. So that's at 0. So x is 0. And here, because that's left 1. No. That's it. That's the only place where cosine's 1. Okay. And where's cosine? A half. all students take calculus. So we'll get one here and here. I think right here. Isn't that point 1/2 root 3 over 2? And that's pi over 6. So x is pi over 6. And then down here, that would be right 1/2 down root 3 over 2 CS. So yes, the cosine's still 1/2, and that is at, oh, no. This is pi over 3. Pi over 3. And this, I believe, is 5 pi over 3. So those are, we have 3 answers. So if x is in between 0 and 2 pi, we have answers of 0, pi over 3, and 5 pi over 3. If it is on the whole entire real number system, so negative infinity to infinity, you would just write those 3 answers with the plus 2 pi k, where k is an integer. You would add that weird step. Let me check this one real fast. What was the question? Let me see. 2 sine squared plus 3 cosine minus 3. I don't know if it's going to show us anything, actually. No. Why don't I take that off? Huh, that does absolutely nothing. If I crank a chart, haha, okay. And then I'm going to hit the wrench and switch it over to radians. Well, look, when it's 0, we got 0. So that was good. That's what we wanted. And then let's try pi over 3. We should get 0. Yes, indeed, that's good. And 5 pi over 3. Yes, okay, yeah, we're fine. Yep, that looks good. Okay. All right, we're going on number 5. Okay, I like these much, somewhat better. Okay, if x is in quadrant 2 and secant of x is negative 3, what's the value of sine of x over 2? So we're going to come to our formula sheet, and we're going to look up the half angle formula for sine. Okay, so I'm just going to Google that on my phone because everybody has, of course, a different cheat sheet. So just, if you don't have a cheat sheet, just Google trig formula cheat sheet, and many will come up, and we're going to come to the half for sine. So sine of an angle cut in half, here's the formula. Plus or minus, we have to decide that. We will in a second. Big root 1 minus cos of your angle over 2. Whole thing's in the root. Okay. So let's see what we know here. We know x is in quadrant 2. And the secant is negative 3. Let's put that over 1. And we know secant is the flip of cosine. So cosine would be 1/3 negative. So let's draw our triangle. So we're going to go left and up because it told us we're in quadrant 2. And our cosine is negative 1/3. So that's the adjacent and that's the hypotenuse, right? Okay, so if we're in quadrant 2, we are somewhere between 90 degrees and 180 in degrees, right? We could think about this in radians as well. And we're taking, that's x. We're taking that and cutting it in half. If you cut 90 in half, you're at 45. And if you cut 180 in half, you're at 90. So our x cut in half is somewhere in quadrant 1. All students take calculus. Well, we're going to be in all. The x over 2, the half one, is going to be in 1. So we don't need plus minus. Ours is going to be positive because our angle is in quadrant 1. Okay, and that's actually all we need this for. Okay, so we are going to be positive. We don't need the plus minus. Alrighty, so now let's just plug and chug. Big root 1 minus cosine is negative third all over 2. Minus minus will turn to big plus. 1 we can turn to 3/3 to give us a common denominator. So we have big root 3/3 plus a third would be 4/3 all over 2. Let's put this over 1. Keep, change, flip. So we would have 4/3 times a half. So that's 4/6, which reduces to 2/3. So if your teacher is not uptight, I would just say final answer. Sine of x over 2 is square root 2/3. If your teacher is uptight and doesn't like a root on the bottom, this is what we'll do. We'll split it into root 2, root 3, and we'll times by root 3. And we would get root 6 over 3. That would also be correct. That's probably a little more correct. And again, we don't need the plus minus because we deduced that this angle was in quadrant 1, so it's positive square root 6 over 3. Last question. Woohoo. If x is in quadrant 3 and tan is blah, 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 what's the value of sine of this? So you're going to come to that cheat sheet again, and you're going to come to double angle for sine of 2x. We already used this one earlier. It's sine of 2x is 2 sine x cos x. And we are in quadrant 3. So there's no plus or minus, so it doesn't actually, it's fine. So let's draw our triangle in quadrant 3. So we'll go left, we'll go down. Here's our x. And we know tan is TOA. O-A. So opposite from x is 4, and our adjacent's 5. And we need to go ahead and get the hypotenuse. So Pythagorean theorem, 4 square plus 5 square equals hypotenuse square. And so that would be 16 plus 25 equals hypotenuse square. Oh, this is actually negative and negative. So negative 4 squared is still 16. Negative 5 squared is still 25. And so this is still 41 equals h squared. Why is it negative? Because quadrant 3, we went left and down. Take the root, take the root. So the hypotenuse is root 41. Okay, so we want to find sine of 2x, so double angle, which is 2 sine x cos x. So look at your triangle. Sorry, I'm going to sneeze. Sorry, did not hit you soon enough. Apologies. Look at your triangle. We need the sine of this angle. So sine is so opposite is negative 4 and hypotenuse is root 41. We're going to leave the root on the bottom for now. And we also need the cosine, so ca. Adjacent is negative 5 and hypotenuse is still root 41. And again, we're going to leave that on the bottom for now. So coming to this red formula, we're going to do 2 times the sine, so negative 4 over root 41, times the cosine, negative 5 over root 41. There's an invisible 1 if you need it. Go right across the top. So 2 times negative 4 times negative 5 would be 40. And the bottom, root times root would be root 41 squared, but that would just bust out. And we have a final answer of 40 over 41 answer. So I knew the root was going to go away. That's why I didn't bother fixing it, though we could have. We didn't need to. Okay. That is it. Sorry for the pen difficulties. Not so much in this one, even though it was starting to go in the other videos. I apologize for the whining, and I hope this was helpful. Bye bye.